Okay.
Okay, so let's just do the first one. So, independent samples. One of the professors at BYU Idaho Math Department collected data from BYU Idaho students to compare the mean wages of BYU Idaho male students to BYU Idaho female students. The students from his classes completed a survey which he then used to analyze if there is difference in these wages. And I need to use those things.
Why isn't
Did
my
you
link working for that?
did you press control?
No. Thank you.
Uh-huh. Did you understand this lesson?
Bits and pieces.
I haven't really liked these last two ones. It seems like they're just mostly like working with the program, you know?
Yeah, that's
Like
been the plus. That's why I passed.
yeah, so I was doing it wrong, so I didn't like it. But now I got it figured out, at least for the last thing.
All right, so I haven't been doing this in Excel, but I'm going to try it just so I don't have to do the whole login process for SPSS. Okay.
Okay, you got it up then?
I do in Excel, which is new for me.
Okay. Yeah, I don't know Excel. I just use the SPSS. Okay, so design the study. What is the research question? So the the research question is, do males or females have a higher mean wage? Right?
Yes.
So how would we put that as a, because it's not,
I mean,
what would
wouldn't
you,
you have to first guess? Let's see. I mean, wouldn't it be more appropriate to have a hypothesis that says,
yeah. So this one says, is the difference between the mean wages of BYU Idaho male students and females, is there a difference? Yeah, what we said. So it has the null hypothesis equals mu1 equals mu2, and then mu1 doesn't equal mu2. So the mean of one doesn't, so the mean of the males doesn't equal the mean of the women, or does equal, or the and then the alternate is the mean of the males doesn't equal the mean of the females.
gotcha.
Okay. So then describe the data collection procedures. Do you know that? Oh, so we're just supposed to. Oh, wait. Oh, so it says students from one of the math department's professors took the survey, which asked how much they make as an hourly wage.
What's that? It's a random sample, right?
Uh, yeah, I guess. No, doesn't it? Yeah. Okay, so that's that. Collect the data. Describe the oh, we just did that. Okay. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So you know how to make a graph, right? Or you don't, not in Excel. You don't know how. Huh?
So, but the data does show that the males have a higher income than the females.
Yeah, that's what I would expect. Huh. Dude. Okay. So you don't know how to do that in
I'm trying
Excel.
to figure out really quick. Excel is a lot more user friendly for me. I have to use it at work all day.
Uh,
Um, what are we supposed to create?
we're supposed to, I think, create a double graph or side by side graph. It doesn't. Yeah. Well. Okay.
All right, I'm gonna create one. I don't know if this came out right. You want to see?
Sure.
Laugh at my graph.
What makes you think I'm gonna laugh at your graph?
That.
Oh, that's a hard one. So you only have one graph. You need to have. I'm pretty sure you're supposed to have two.
Oh.
In the reading, it tells you how to do it for Excel too. You're supposed to use. It has a file for you to go to.
Does it?
Yeah.
I saw it earlier. Sorry if I'm not here all the way. I feel like I'm about to pass out.
It's okay.
Sorry, what are we doing?
So we're trying to figure out the summary statistics to describe the data. Oh, so we're not even supposed to be doing this part. We're just supposed to do the two different graphs and then get like the standard deviation and the mean and all that stuff. You know how to do that?
I do an SPSS, but I got to get logged into that.
Yeah.
Want to screen share that?
That my SPSF?
Yeah.
Okay. Yeah. Okay. So I'm just going to do analyze descriptive statistics, explore. So we want both. When we do gender? Oh no, that's not.
Your screen's not all the way there. Uh-oh.
Because it's not covering it all. Is that better?
Yeah.
Okay, so in Germany. How would we do that? Because it's okay. So I went to analyze and compare me. This one, and I got to here. And do we? Maybe we do that, and
should be something
then
on there for gender, right, or sex?
yeah, maybe that.
Okay.
Right? Oh golly. Let's see if that turns out. Okay.
There you go.
Yeah, so that okay. Yeah, boom. Okay. So for females, the mean is 9.7, and males, it's 11.94. So we know how to do that, right?
Yes.
Okay. Now we know. So then
Let me check something out really quick. What do you have the mean is?
mean is 1 second. For which one?
For females.
Females, it was 9.76.
Do you want to see? Do you know that's so much easier in Excel?
It is?
Yeah. Can I show you real quick?
Sure.
Do you use Excel ever?
Nope.
Gosh, I look like I'm looking in a temple mirror. So this is Excel. So all you're going to do is on the left-hand side, you see the Fs.
Yeah.
You're just going to highlight the wages until you reach the end of F. And then your mean is right there.
Where's your mean? Where's this shot?
Where it says average.
Oh.
You see my arrow?
Okay, yeah. Your screen it's a little blurry, so it's hard to read. But nice. That's nice.
Yeah. A lot quicker, huh?
Yeah.
And
Okay,
then
so
I can, get the same with the male by going there, and that's for men, 7.93.
yeah. Sweet. So we both know how to do it on our different programs. Okay, are the test requirements met for this test? I'd say yes, because the sample size is larger than 30.
Yes.
And then compute the test statistics. Okay, so for that,
What exactly do they mean when they say compute the test statistics?
so the test statistic is the same as the z-score, but when the standard deviation is unknown.
Okay.
So I don't know how you do that on SPSS. I mean, not on Excel, but for SPSS, I know how to do it. At least I think I do. So do you know how to do it on Excel?
I'm about to find out really quick. Um, okay, I've got a formula for doing it on Excel. Yeah. Do we know the standard deviation though?
No, we don't know the standard deviation for this one. That's why we have to find t and not z.
Okay. Oh, I got it. I got it.
Yay!
Z-test.
Well, t-test.
Z, right?
T, as in Taylor.
Oh.
Z is when we know the standard deviation.
Okay. Give me 1 second. Oh. T-test, right?
Yeah, t-test.
I think I almost have it.
Yay!
T-test. Oh, I'm doing something wrong. This isn't my entering enough arguments.
You're not entering enough arguments?
Yeah.
What's that even mean?
I haven't given it enough information.
What'd you put in? For SPSF, you have to put in SPSS. You need to put in the wage, and then you had to make this thing what's called a automatic recode, and then you had to put that in with the wages.
Yeah, okay. You know, I'm trying to teach myself how to do something new at midnight, and it's just not a good idea.
There's instructions how to do it on the lesson for Excel.
I know, I don't remember the lesson.
Yeah.
Okay. You know what? I'm not going to get that tonight.
Okay, we'll just rely on mine, and then you can figure it out some other time. Okay, so then with that, it does all those, so C, D, E, and then F. The P value is 0.069 for two-tailed, which is, that's what it is. So we fail to reject the hypothesis because it's higher than 0.05. And then yeah. And then present your conclusion in a form of English statement. So we have insufficient evidence to say there is a difference between wages of male and female BYU Idaho students. And then gather the testing. Rather than testing a hypothesis, now say you just want to estimate difference between female and male wages at 95%. So that's also in the thing that we just did that gives you that answer as well, which is negative 0.17622 and then 4.52858. And then now interpret the confidence interval you build above. There we can see there's insufficient evidence using the confidence interval method because there's zero is included. So when 0 is included, then there's not enough evidence, but when 0 isn't included, then there is enough evidence to reject it. And then yeah, that's okay. You want to take the group quiz?
Yeah, let's do it.
Okay. Hopefully we'll be good. Okay. So yeah.
Is this week supposed to be like a review of some of the other stuff we've done?
I don't think so.
Okay.
So what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? A and B, right? Yeah, A and B. A test statistic for a hypothesis test comparing two means with independent samples is a t-score.
Yeah, t-score. Sorry. It's a test.
Two samples are independent if knowing which subject will be in group 1 determines which subject will be in group 2. No. Knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2. Yeah. Okay. Now we're done with the easy ones.
You know what? It looks like I got to pull open a data file anyway.
Yeah,
so
me too.
Having SPSS. I have to do it, right?
Yeah. Dentist office bills. Dentist office bills. Huh. Seems like okay. You got it up yet?
Nope, it'll take just a few seconds.
Okay, just tell me when it's up for you.
Oh, don't do this to me. There we go.
Okay, so use the data file dentist office bills to answer questions 6 through 11. The data represents simple random samples of dentist bills.
No, not ready yet. It's preparing.
So I'm just reading the
Okay.
question. What the experiment is. The data represents simple random samples of dentist bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Use the null hypothesis of null hypothesis mean 1 equals mean 2 and alternate hypothesis mean 1 is less than mean 2 with a significance level of 0.1. Okay, so are you ready yet?
Nope. You see where I am?
Yeah, so almost ready, I guess. I don't know. Oh, you're not even in the test yet?
I am, but I'm logged in on my main screen. Like I have to log into this remote server in SPSS.
Weird.
We have the multi-screen thing going.
Yeah.
I have too many classes to be working 50-hour weeks. Got 5 classes.
Yeah.
Oh, do I have to log into the test twice?
I don't know.
Oh no, I don't. I just have to. I have to go to the place where I can download the.
Information.
Yeah.
Yeah, it's
We're
in
gonna
the
have to
reading.
look that
You
up.
can go to the reading and click a link. Or yeah.
There should be like a resources, right?
I don't know. I just always click on it on the reading.
Gosh, why didn't I see that before?
Yeah, I know, right? That would have been helpful.
T distribution applet? Okay.
So, I would just look in the reading. There's a link on it.
It's in the reading?
Yeah. For this lesson, probably last lesson too. But... So down on the same page. You're on the right page. You had to just click the link. Inferences for 2 means.
Okay. And then it'll have the
yeah, so go down some. Yeah. Whoa. Up. Right there. See reading practices? So open that in a different tab. Over to the right. Up. Right before answer the phone. Yeah, there. And then scroll down to SPSS until you find the dentist something.
office bills.
Yeah. Ta-da!
What are we looking for?
Okay. So, I don't remember. We need to find the degrees of freedom. So, okay. So we basically have to do everything. Okay. So first, we have to. First, we go to graphs, legacy dialogues, and then histogram. Or do we have to do? I don't think we have to. Yeah. I don't know if you have to do that. Well, whatever. I'm just gonna do it because I know. Nope. Okay, we don't do that. Okay, we go to transform, and then we go to automatic recode.
Hold on, I'm stuck. Okay, not stuck anymore. All right, so we're transform and then automatic recode.
Yeah. Okay, so we're.
Oh.
So do you think we're doing it with the bill? Yeah, we're doing it with the bills.
Yes.
Okay, so then we put it into the variable new name. And then new name, you put code, all caps. That's what they said. And then do add new name. And then you press OK. And then one second, I have to move.
All right.
Yeah. So do that. And then so now we have a new code thing. So then we go to analyze, compare means, one independent samples t-test, and then we put our
Dentist bill on the code.
wait, what? Yeah, Dennisville, and then code for the grouping variables. And then define groups, we do 1 for group 1 and 2 for group 2. And then continue. Okay. And that was
something wrong.
Yep, me too. Golly. Okay, what did we do wrong? Let me try something else. Oh, okay, maybe.
We should put the city in, shouldn't we?
I tried that. It doesn't let you. Yeah, I don't know what we're doing wrong. Ugh. Maybe we did the code wrong. Maybe the code is supposed to be the cities.
That can't be it. All right. Let me think.
What?
So let me think for a second. What am I trying to do? You're trying to figure out the degrees of freedom, right?
Well, yeah. Basically everything that one chart gives us that we had that last time. Hey, I figured it out.
Did you?
Yeah, so we were supposed to do the transform automatic recode for the cities, not the dentist
Office.
bills.
Oh yeah. Okay. All right. Try again. Transform. City. Why is it not letting me do that?
I had to exit out and go back in.
All right. Yeah. Let me do the same. Hey, it's approaching 1 o'clock and I'm not doing too good.
Yeah, I know. I'm sorry.
Dentist office.
You got it yet?
Almost.
Okay.
Oh, okay, great. So there's Idaho Falls and Rexburg.
Right.
Okay. And now I want to. We want to create a graph still?
No. You go to Analyze, Compare Means, Independent Sample t-test.
And then of code, right?
And then, oh gosh. 1 second, I can't remember just off the top of my head. Analyze, you do dentist bill for test variable, and then the code for grouping variable.
It's showing me question marks.
That's fine. Just press define groups, and then do 1 for 1 and 2 for 2. Then press OK, right. And then press OK.
Work.
You got it?
Yeah.
Sweet. Okay. So the standard deviation is 208.875. Well, what do we do? Because that's the standard deviation for Idaho Falls. And then Rexburg is 206.6.
I thought I was asking for, hold on. Go back to the question.
Oh, it is for Rexburg. Oh, okay, yeah. So 206. Right. 6. Nice. Okay. You finding everything else fine?
Yeah, just I think my brain's checking out a bit.
You what?
Brain.
Oh yeah.
I'm like literally falling asleep. Okay, Rexburg. 88.16.
And for 9, don't forget to put 0.333 instead of 0.66 because it's less than, and it's not two-tailed, it's one-tailed.
Wait. This 2-screen thing is killing me. Okay.
So we only have 15 more minutes before.
You do. I'm already past time.
Well, it's for Mountain Standard Time, so it's 12:55 for you.
Oh, okay. Why am I not having my answers on here?
What?
I don't have the degree of freedom on here.
You should. It's the DF right after the T. Yeah.
Oh, I see. Okay.
And it's the bottom number, not the top number.
Standard deviation for expert is
206.637.
the test statistic. What do you have for the? I don't see p-value on here at all.
It is the sig, and then in parentheses two-tailed, and then you divide it by 2 because it's
Two-tailed.
one-tailed instead of two-tailed.
Correct. Evidence. What are we trying to prove again?
What do you mean?
It's asking if we're going to reject it or accept it.
So we failed to reject because the level of significance was 0.1.
Okay. Do we do the test statistic? That's going to be the 4.34, right? Or 0.434?
Negative 0.434.
That's not even a number. Okay, so we're going to do the other data file.
Right.
Oh, no. What's the name of that file?
It says freshman dinner.
We did a data file for freshman. I need to find something better to do.
For real.
Okay. Let's do,
Okay, so what is the appropriate alternative hypothesis?
I'm not on there yet.
Okay.
It didn't come up. Okay. What are we looking for?
So for 12, we're just figuring out what the appropriate alternate hypothesis is. So it's mu1 doesn't equal mu2 because it says you suspect that freshmen from Utah cooked dinner for themselves a different number of times than freshmen from Colorado. So it doesn't say less than and greater than.
Second one.
Yeah. Okay, so then we're trying to find the T, P, and T and P, and then the confidence level at 95%.
All right. Uh-oh. I undo.
I have no idea.
I don't know what I pushed. So now we're looking for the test statistic.
Correct. So you have to do first, you have to do the transform, automatic recode, and then do state, and then code it. We'll put code for the new name.
Okay.
You did that?
And I've got Colorado and Utah now.
Okay, and then analyze, compare means, independent sample, teeth sample test. You there?
State is the test variable.
Freshman's the test variable, and then the code is the grouping variable. And then you have to do define groups 1 and 2. And then okay, and you should get it.
Test it. Yes. Well, we have two different answers for test statistic.
Because one is where equal variance is assumed and one is where equal variance is not assumed. For this class, they said we always do the not assumed one.
Okay. Limit of confidence minus 5.137.
Yeah.
Number is 2.204.
Okay. You got it all?
P-value is 0.185, right?
No.
Right?
I got 0.410. Where'd you get 0.185?
Wrong column.
Oh, okay. And then fail to reject the null.
Yes.
Okay, you got it all?
I think so.
Okay, let's see how we do. Yay! I got 100. How about you?
Oh, wow. Yeah, I got it too.
Yay! I think, is that one of our first 100s?
SPSS isn't that bad.
Yeah, I like it. Okay, so